Welcome to our whiteboard animation on potentiometric titration. Potentiometric titration is a technique used in chemistry to determine the concentration of an analyte in a solution. What is potentiometric titration? Potentiometric titration is a direct titration of a redox reaction. Also, this type of titration does not want any indicator. Potentiometric titration measures the electric potential of the reaction. We can consider some examples as follows. The first example is permanganate iron convert 2 manganese 2 plus ion concerning ferric iron convert 2 ferrous iron. The second example is ferric ion converts 2 ferrous ions concerning certain 4 plus iron convert 2 cerium 3 plus iron. This video will discuss the titration of cerium 4 plus iron and iron 2 plus iron. We have to use a mathematical model for this calculation to find the potential of considered burette readings. Consider the following half cells. We put 100 milliliters of 0.05 m ferrous iron solution in a titration flask. We have to acidify the reaction by using sulfuric acid. We usually have to find the potentials of the equivalence point before and after the equivalence point. We can calculate the potential at the equivalence point using the below equation. In an earlier video, I mentioned how to find the equivalence point potential. There is a link in the description. Watch it before this video. Then, we consider the volume of cerium 4 plus before the equivalence point if we add 5 megaliters of 0.1 m cerium 4 plus to the titration flask. Before the equivalence point, ferrous ions are the predominant to get the potential of the point. So, we must consider iron 2 plus and iron 3 plus as significant components when finding the potential before the equivalence point. After adding 5 megaliters of cerium 4 plus to the titration flask, iron 2 plus ions convert to iron 3 plus ions. So we have to find out iron 3 plus cancellation in the solution. The stoichiometry between cerium 4 plus and iron 3 plus is 1:1. So, reacted cerium 4 plus amount is equal to form iron 3 plus amount. But the medium may have some small amount of cerium 4 plus. But we consider all the cerium 4 plus amount reacted with iron 2 plus moles. So, in this case, unreacted cerium 4 plus concentration is negligible. Then we have to find out the remaining iron 2 plus concentration. When we find the remaining iron 2 plus concentration, we have to subtract the reacted moles of iron 2 plus from the initial moles of iron 2 plus moles. Also, in this case, unreacted cerium 4 plus is considered negligible. In the above case, the total volume of the titration flask is 55 megaliters. Using the Nernst equation, we can find the potential of the given point. If you don't know the Nernst equation, watch the Nernst equation video mentioned in the description. Now, we are going to consider a point which is coming after the equivalence point. We are adding 25.1 megaliters of cerium 4+ to the titration flask. After the equivalence point, cerium ions are the predominant to get the potential of the point. So, we must consider cerium 3+ and cerium 4+ ions as significant components when finding the potential after the equivalence point. After adding 25.1 milliliters of cerium 4+ to the titration flask, finish all iron 2+ ions into iron 3+ ions, and no longer reaction occurs after the equivalence point. So, the formed moles of cerium 3+ are equal to the reacted iron 2+ moles. So, in this case, unreacted iron 2+ concentration is negligible. We can calculate cerium 4+ concentration by subtracting reacted cerium 4+ amount from the total amount of cerium 4+ added. Also, in this case, unreacted iron 2+ conversion is negligible. Cerium 4+ concentration can be calculated by subtracting reacted cerium 4+ amount from the total amount of cerium 4+ added. Also, in this case, unreacted iron 2+ conversion is negligible. According to the Nernst equation, the potential of the system can be calculated.